Welcome to Astronomy Daily, your daily guide to what's happening across the universe. I'm Anna.
And I'm Avery. It's Wednesday, the 6th of May, 2026, Series 5, Episode 97.
Big show today, Avery. We've got a world beyond Pluto that has absolutely no right to have an atmosphere, and yet there it is.
A rule breaker in the Kuiper belt, I love it. We've also got 12,000 photographs from Artemis II landing on the internet, and a quick look at where Artemis III is headed.
Blue Origin's moon lander gets a very tough test. The sun turns out to be tidying up our orbital clutter. Drones could be the key to finding water on Mars.
And a certain comet has done a handover. Northern skies, it's been emotional. Southern skies, here it comes.
Let's go.
All right, let's start with what might be my favorite story of the week. There is a little frozen world out beyond Neptune, a trans-Neptunian object designated 2002 XV93, and it appears to have a thin atmosphere.
Which sounds nice, except that this object is only about 500 kilometers across, way too small to hold an atmosphere.
Exactly. The scientific understanding has always been that small icy bodies in the outer solar system just can't retain gases. They're too cold, their gravity is too weak. Pluto is the one exception, and Pluto is a dwarf planet. This thing is much smaller.
So how did they find it?
Stellar occultation. The team, led by Dr. Ko Arimatsu at the National Astronomical Observatory of Japan, watched as 2002 XV93 passed in front of a distant star. If there's no atmosphere, the star disappears instantly. Instead, the light faded gradually. That gradual change is the signature of an atmosphere bending the starlight.
So what created the atmosphere? Do we know?
Two leading theories. One is cryovolcanism, basically ice volcanoes venting internal gases. The other is a relatively recent comet impact that blasted material into space. If it's the latter, the atmosphere could disappear within 1,000 years. We might be looking at this at an extremely lucky moment.
Cosmically lucky. And the James Webb Telescope could potentially work out what the atmosphere is actually made of.
That's the plan. Webb could detect the chemical signature, and if the density is dropping over the next few years, that would point to the impact theory. If it stays stable, it's probably cryovolcanism, an ongoing process.
What I love about this is that it's not just interesting, it actively changes the rulebook. If even this small world can hold an atmosphere, even temporarily, the Kuiper belt could be a much more dynamic place than we thought.
Dr. Arimatsu put it well. This challenges the conventional view that small icy worlds in the outer solar system are mostly inactive and unchanging. And I think that's the story here. The outer solar system is alive.
So the Artemis II mission ended almost a month ago, but the images just keep coming.
They really do. NASA has quietly uploaded more than 12,000 photographs taken during the mission. The full archive is now publicly accessible on the Gateway to Astronaut Photography of Earth website.
12,000. That's a lot of scrolling.
It is, though fair warning, some of them are duplicates or near identical frames. But even filtering for the standouts, there is extraordinary material in there. Close-ups of the lunar far side that are the highest resolution images ever taken by a human hand. Star trails, Earth vanishing behind the moon, the Earth-set shots.
And they were shot on a combination of professional Nikon cameras and modified iPhone 17s. The crew left all the photos unattributed, a deliberate decision to frame it as a shared human achievement.
Which I think is lovely. And NASA says the archive isn't just for public enjoyment. It's a foundational data set for Artemis III mission planning. These images will help determine where to land, how terrain looks under different lighting conditions, and more.
Speaking of Artemis III, any update on that front?
Yes, actually. The Artemis III Space Launch System core stage arrived at Kennedy Space Center by barge on April 28th. It's now in the Vehicle Assembly Building. The mission is targeting mid-2027, and the plan, as confirmed recently, is to launch into a 460-kilometer low Earth orbit to test docking between Orion and at least one of the commercial lunar landers. That's the critical rehearsal before Artemis IV attempts the actual moon landing in 2028.
So we went from 0 humans on the moon since 1972 to Artemis II flying a crew around the far side to already stacking the next rocket. It's been quite a run.
It really has.
Blue Origin's Blue Moon Mark 1 lunar lander, nicknamed Endurance, has completed its thermal vacuum testing at NASA's Johnson Space Center. What does that actually involve?
So, Thermal Vacuum Chamber A at Johnson is essentially a 90-foot tall can that sucks out all the air and then cycles through extreme temperatures, simulating what a spacecraft will encounter in space and near the moon. You're recreating the environment of deep space right there on the ground in Houston.
And Endurance passed.
It did, which is a significant milestone because MK1 is scheduled to fly to the moon's south polar region later this year. It's an uncrewed cargo lander, no people on board, but it's carrying a couple of interesting science payloads.
What are those?
There's a stereo camera array specifically designed to photograph the engine plume interacting with the lunar surface during descent. That might sound niche, but it's actually really important. Understanding how rocket exhaust disturbs the regolith helps you design safer landing approaches for crewed missions. The other payload is a laser retroreflector, which helps orbiting spacecraft precisely locate the lander.
And there's a bigger picture here. MK1 is a pathfinder for MK2, the crewed version that Blue Origin is developing for future Artemis missions.
Right. Every lesson learned from MK1 feeds directly into that. In the commercial lunar lander space, you really can't afford surprises when there are humans on board.
All right, moving on. New research published today in Frontiers in Astronomy and Space Sciences has confirmed something scientists have long suspected. Solar activity directly affects how quickly space debris falls back to Earth.
Walk us through it. How does the sun's activity move things in orbit?
So the sun goes through an 11-year cycle of activity. At the peak, it's pumping out more radiation, which heats Earth's upper atmosphere, the thermosphere, causing it to expand. Low Earth orbit suddenly becomes a slightly thicker air environment. Objects passing through it experience more drag, which slows them down, lowers their orbit, and eventually brings them back.
And the new study tracked this happening in practice?
Yes. Ayesha Ashraf and colleagues at India's Vikram Sarabhai Space Center tracked 17 pieces of debris over 38 years through 3 complete solar cycles. They found a really clear threshold effect. Once sunspot numbers hit roughly 70% of the cycle's peak, the debris started dropping noticeably. Below that threshold, the objects held their altitude. Above it, they steadily descended, a staircase pattern tied directly to the solar cycle.
So the sun is naturally clearing some of the junk for us.
In a sense, yes. And the timing matters enormously. We're currently near the peak of solar cycle 25, which means right now is actually a period of accelerated orbital decay for a lot of debris. For mission planners dealing with the growing threat of collisions in low Earth orbit, understanding this cycle and knowing when the sun is most actively doing its housekeeping could be operationally very valuable.
It's one of those stories where the universe turns out to be more interconnected than you'd expect.
Always is. Now, before we move on, a quick reminder to check out the great deals our sponsor NordVPN has in place for you right now. Save big and get the best in online protection. When you're ready to find out why we love NordVPN so much, simply click the link in the show notes. You'll be glad you did.
Next up, Mars has hidden ice. We've known that for years. But the challenge is finding exactly where it is with enough precision to actually use it. A new study says radar-equipped drones could be the answer.
Yes, this is from a study published in the Journal of Geophysical Research Planets. Mars has what are called debris-covered glaciers at its mid-latitudes, basically huge reservoirs of water ice buried under a blanket of rock and dust. That rock actually protects the ice from sublimating away into the thin Martian atmosphere.
And the orbital radar, SHARAD, on the Mars Reconnaissance Orbiter, can see the ice is there, but can't resolve the exact boundary between ice and overlying debris.
Exactly. SHARAD operates from orbit, and the resolution just isn't fine enough for that kind of precision. What the researchers proposed is flying a low-altitude drone with a ground-penetrating radar to map from much closer up. They tested this concept on Earth over a rock glacier in Wyoming, and the drone could see that boundary clearly.
And Ingenuity already showed us that powered flight on Mars is possible.
That's the key precedent. A radar-equipped successor drone doing subsurface science rather than just aerial photography is a completely logical next step. For any future human mission that relies on in-situ water, and they probably will, this kind of precise ice mapping ahead of time could be genuinely mission critical.
Finding your water supply before you arrive rather than hoping for the best.
Exactly. Scout ahead. It's what explorers have always done.
And we close today with a handover. Comet C 2025 R3 PanSTARRS is done with the Northern Hemisphere, and it's now arriving for southern skies.
For our listeners in Australia, New Zealand, South Africa, South America, this is your moment.
The comet passed perihelion on April the 19th when it came within about 75 million kilometers of the Sun. It may have briefly reached naked eye visibility around that time. It's now fading, but it's also moving away from the Sun in the sky, which makes it much easier to actually observe.
And there are some genuinely exciting deep sky encounters coming up. From May 10th to the 12th, C 2025 R3 will pass within about 2 degrees of the Orion Nebula. For anyone with a telescope or even decent binoculars, that pairing is going to be something special to photograph.
How bright is it now?
Fading, but still a solid binocular target. The absolute best conditions will be around the new moon on the 16th of May. That's when the skies will be darkest. Look low in the western sky after sunset. Clear horizon is your friend.
And is it worth the effort if you're a casual observer rather than a dedicated astronomer?
I'd say yes, because this comet is on a hyperbolic trajectory. It is not coming back. Once it leaves, it's gone from our solar system forever. There's something quite remarkable about that. Looking at it in the sky, knowing you're watching a one-way journey.
A visitor from the deep that won't pass this way again.
Exactly. Go see it while you can.
And that's Astronomy Daily for Wednesday, the 6th of May, 2026, Series 5, Episode 97.
What a lineup today, from a frozen world growing an impossible atmosphere, to 12,000 photographs from the moon, to a comet making its southern debut.
If you enjoyed the show, please subscribe and leave us a review wherever you listen. It genuinely helps more people find us.
You can find us online at astronomydaily.io and follow us on social media at AstroDailyPod.
I'm Avery.
And I'm Anna. Keep looking up.